So now I will show you another way of looping. Remember I told you last time that loops concept, but I intentionally didn't teach one topic, that is recursion. Why didn't I teach recursion? Because in order to implement recursion, you must know functions. So now is the time when I will show you how to use recursions. So let's get started. But before coding things using recursions, let's understand recursion using some real life scenarios where you actually use recursion. But you may not realize it, but you actually use the concept. And recursion is not at all a computer science topic. It is a mathematical concept which you are actually using inside computer science. Okay, and interestingly, computer science and mathematics are very related field. Like for example, function is a chapter in my +2 level mathematics. It was a chapter. So functions is a mathematical concept which you are applying into the field of computer science. So that's how related these things are. Okay, so now let's open paint to understand recursion. So let's say this is a ticket counter. This is where you will buy tickets. So okay, let's let's not make it pink. um let's keep it black. Okay, now if I say this is a ticket counter. Okay, this is where you will buy tickets, and there is a long line of persons. So let's say this is a person. Let me draw a person, and I'm really bad at drawing, so please don't mind if I draw bad. So let's say this is a person. Okay, this is a person, I know. Okay, I'm drawing a person, so just hold on. Okay, control Z. Without any perfection, I just draw person. Now what I'll do is I'll just copy paste this one because I cannot draw more. Control C, control V. So I will take this one. Just copy this, paste this. Okay, one. Control C, control V. Take this, put it here. Control C, control V. Now put it, oops, put it here. Okay, so now this is you. Okay, let's say, yeah, is there, okay, let's just use it. You, me, let's say Bob, and this is John. Okay, so let's say you want to know, okay, this is a queue, right? This is a queue. So what I mean is that this guy will go first. Okay, this guy will go first and buy a ticket. Then this Bob, then John, and then finally you. But let's say you do not know how many people are standing. Okay, let's say you cannot see how many people are standing. So how can you know the number of people in a queue? So what you will do is you will ask the person in front of you that how many person are in the queue. So obviously that person also won't know the answer. So that person will ask the person in front of him the same question, hey, how many people are there in front of you? And finally that person will ask the person who is the first person in the queue. Now that person will answer, no one is in front of me, so 0. So if that person says 0, Bob will say 1, John will say 2, and finally you will get to know that you have 3 people in front of you. So let's see this in action. Can I make this a big? Can I make this big? Okay. So yeah, you ask John how many people are there in the queue. John doesn't know the answer. So John asks Bob, hey Bob, how many people are there in the queue? Bob doesn't know the answer. So Bob finally asks me. Now I know the answer because no one is in front of me. I am the first one in the line, right? So I will say I have 0 person in front of me. Now Bob will understand Bob has 1 person after him because this is Bob, this is another person, so there is 1 person. Now Bob will tell John that I have 1 person in front of me, so John will understand that he has 2 person in front of him, and finally John will tell you that he has 2 person in front of him. So now you can understand that there are total 3 person in front of you. So that means there are total 4 people including you, right? So this is the classic example of recursion. You go this, then this, then this. Now you come back in this way. He will tell you 0, he will tell you 1, you will tell him 2, and now he knows that he has 3 person in front of him. So this is a classic example of recursion. Now let's see another example. Okay, so for that, let me open my camera. Yeah. Yeah, so have you seen Russian doll? It's called Matryoshka dolls or something like that. I do not know the term actually. So there are things like Russian dolls. So there is a big doll, this big doll. If you take it out, there is another doll inside it. It is smaller than the earlier one. Now you take this up, there is another smaller doll inside it. You take this up, again there is another small. You keep this, you keep doing this until you reach the smallest doll. Now if I give you a Russian doll and tell you that, hey, tell me how many dolls are inside it, you won't be able to tell the answer because you do not know how many dolls are there unless and until you open it. So you start from the largest one and keep reaching the smallest one. You start from the largest, then small, 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 and then you go to the smallest one. Now you can backward count. So the smallest one is 1, then the bigger one is 2, then the bigger one is 3, and finally the biggest one is 4. So you can say, hey, there are 4 dolls. So now many of you may not know what Russian dolls are. So let's use our friend Google to understand what Russian dolls are and how it uses recursion. Isn't it amazing, guys, that real world objects use recursion? It is, right? Let's open what are Russian dolls. Russian dolls. Let's open it up. Yeah, got it. Matryoshka doll, as I see it. So have you seen these dolls ever? Let me open this picture. Yeah, this is a perfect one. So yeah, so this is the biggest doll. This is the smaller one. This is again smaller than this one. This is smaller than this one. This is smaller than this one, and this is the smallest one. Okay, can this be bigger? Then it would have been better. Okay, it will take some time because I have a slow internet connection. Really sorry, guys. Phew. No, damn. I just want the photo. Is there a photo? Hmm. Okay. Okay, leave it. So this is the biggest doll. Inside this doll, there is this 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 doll. And now you cannot open this anymore. This is the smallest piece. So now you have to stop. Now you have to stop. This is the base case. Remember, the case where you have to stop is the base case, right? And going from here to here is a recursion case. You are opening each doll at a time. So now let's see this in YouTube. Let's open, Russian dolls video. Let's see this in action. You can obviously skip ahead if you know what a Russian doll is. You can just skip ahead, and if you understood, you can definitely skip ahead. This is for them who couldn't understand. Okay, see this very carefully. Okay, this is the biggest doll. So as you can see, the biggest doll has been opened. So there is another doll inside. This is smaller than the biggest one. So again, the second doll has been opened. There is another doll inside it. So as you can see, this is the smallest doll. You cannot go after this. Okay, is there a pencil I can draw with? Is there a pencil? I need help, little help here. Okay, so yeah, I have a pencil. So if I use this one right here, okay, I use this one. Yeah, this one. Again, I cannot use this. Leave it. So this is the smallest doll. Now he will be going backwards. Okay, smallest doll, then the bigger one, then the bigger one. Then again the bigger one. Okay, finally the biggest one, right? Now if I tell him that how many dolls are in total, he will exactly say the number. But at this stage, okay, at this stage, if I would have asked him that how many dolls are inside this, he couldn't have tell, right? So you are going from biggest to smallest. Now you are counting from smallest to biggest. That's how Russian dolls are, right? So again, let's demonstrate this. The second example. Let's understand the examples. Okay, remove all these things. Okay, so yeah, now so this is our biggest doll. Let's say this is the biggest doll. Okay, C Control V and make this a little bit smaller. Okay, Control C Control V, make this again smaller, and now Control C Control V, make this the smallest. Okay, I'm not going any further. So after opening this one, you get this one. After opening this one, you get this one. Finally, after opening this one, you get this one. And you try to open this, but it won't open because this is the smallest doll, right? So now you have started from the biggest one. So starting from biggest, you go to smallest, right? So from this to this, from this to this, and from here to here, right? Now you are counting backwards. 1, 2, 3, and 4, right? So this is the same as I have 0 person in front of me. He will say I have 1 person in front of me. This will say I have 2 person in front of me. And he will say there are 4 person in front of me. Now you can see, including this one, you have total 4 dolls. These 3 and plus this one, this guy over here. So you have 4 dolls, right? So this is the concept of recursion. Let's remove this. Let's remove this. So I can do things like, there are various puzzles we can solve using recursion, and we can actually replace loops. So how can we do this? So there are cases where we can actually replace loops with recursion. The scenarios are sometimes critical, or sometimes it is quite complex, but we can actually replace loops with recursion. And let's start let's start with some examples that are easy to understand. For example, factorials, or let's say you give a number. Let's choose a random number. Let's say 3. So you want all the numbers starting from 1 to the number you gave, which is 3, to add. So 1 plus 2 plus 3 gives us 6, right? 1 plus 2, 3 plus 3 gives us 6, right? This is the way you have worked till now using loops. You start a for loop from 1 and go to 3, and for every number keep on adding to a temporary variable. Okay, 1 you add it, 2 you add it, 3 you add it, stop. That's how you have worked until now. But in recursion, you go the back way. You start from 3, then you add 2, then you add 1, then you stop. And when do you stop? When it becomes a 0, right? When it becomes 0, or you can say when it becomes 1, that's all. When it becomes 1, you stop. You do not go any further. You do not make it 0, because adding 0 won't give you anything. So it's better to stop at 1, right? So what is the base case here? Base case is the case where you stop recursion. What is the base case? The base case is when the number becomes 1. This is the base case. Okay. Now what you will do is let's count 3 backwards. 3 minus 1. What is 3 minus 1? 2. 3 plus 2, 5. Now what is less than 2? 1, right? Now 3 plus 2 is, okay, 5 plus 1 is 6. So 3 plus 2 plus 1 is same as 1 plus 2 plus 3, right? In loops you go 1 plus 2 plus 3, although you can obviously go the reverse way, but still you go this way, 1 plus 2 plus 3 in loops. But in recursion you go 3 plus 2 plus 1. it gives you the same result, right? Now, recursions are much faster as compared to loops. But there is one problem, okay? There is one problem when using recursion, in Python especially. In languages like C, there are no problem. Um, and that's a big problem because, recursion in C is dangerous as hell. Pointer arithmetics with recursion is dangerous as hell. It can break it can really break your system. You can damage it really. C is very, very powerful, very powerful. But in Python, there is a limit. You cannot recurse more than 1000 times. Once you cross that limit, you will get a recursion error. And I will show that. Okay. So now let's start coding. Let's start the Python interpreter. Now let's define a function. Let's define a function. And the name of the function is add loop. And you take a number as a parameter, and you say define a temporary variable called sum, and you start a for loop for x in range 1 to number plus 1. Now, one second. Now for every number you keep adding to this sum variable, right? Finally you return it from where it has been called. So return sum, right? So this is the function, and let's see if it works or not. Print add loop, right? Okay, add loop 3. This is the argument that we passed. This is the parameter it required. So again, let me remind you the difference. Argument is what we pass, what we give to the function, and parameter is what the function needs, right? So we pass 3 as an argument. So now number is 3, right? Sum is 0. It starts a loop from 1 to 4, and it adds 1 to the sum, then 2, then 3, then it stops. So 1 plus 2 plus 3 gives you 6, and then it finally returns the sum. Okay. Now there is another way we can do this using recursion. We said we define another function and say add recursion, and again recursion also takes number, and I will explain later on. Just let's code first, okay, and I will explain later on. Now this is the base case. First, always remember you must add base case first line while defining functions. Remember this thing. So the base case is if number less than 2, or let's say number less than 1, you can say number equal to 1, right? Return 1, right? Else, okay, do not add this else statement. This is a very big mistake. Do not add this, right? Just say return number plus add recursion number minus 1. Now let's see if this works or not. See, it works perfectly. It works perfectly. Now I will explain this. Just hold on a second. So it works, but how? You may ask me how. So this is how it works. Okay, let's start understanding this. Now, you pass 3 as an argument. So number is now 3. It checks if number equal to 1. Is the number 1? No, it is 3 right now. So it skips this thing. Now it returns number that is 3 plus it calls itself the name of the function, okay, add recursion. So it returns number that is 3 plus add recursion, the name of the function, and now it passes number minus 1 as an argument. So what is number minus 1? 2, right? 3 minus 1, 2. So number minus 1 is 2. So it passes 2 as an argument to the function. Now, this is 2 right now, okay? If the number is 1, so return 1. So it skips it. Again, when it is for 2, it returns number plus add recursion number minus 1. So 2 plus add recursion, again it calls the function number minus 1, that is 1. Now for 1, if number equal to 1, so this is true, return 1. So 2 plus 1 plus the previous one 3 gives you 6. Now you may ask me that there are two return statements in a single function. Is it possible? Yes, it is 100% possible. But remember this thing. Once you say return, you cannot go back to the function of that instance. Okay. Once you say return, you actually exit from this function. You exit from this function, right? And you cannot come back. In order to come back, you must call again. So now let's understand this thing in Paint. Okay. Oops. Control C. Open Paint. Can we paste it directly? No, we can't. Okay. If we take a text box, say things like this. Okay. Yeah. Perfectly okay. Fine. Okay. Now let's understand this a bit. Okay. First, okay, let's take the brush. So now we pass 3 as an argument, right? So 3 comes here. 3 comes here. If number equal to 1, nope, it is not. Return number plus add recursion number minus 1. So what is the value of number right now? It is 3. Now add recursion number minus 1. So it passes 2 as an argument to the same function. Now it again passes to the same function, right? It calls itself again. So for this, the first statement is 3 plus, okay, let's just write this, okay? That will be better, much better. So the first it does, these are the steps, okay? Step 1, it returns number that is 3 plus add recursion 2, right? This is the first step. Okay, so this is the first step. In the first step, it returns 3, this expression. It returns this expression. Now, inside this expression, it calls itself add recursion 2. So what is the argument here? The argument is 2. Right here, this is the argument. So now, number is 2, right? Now, if number equal to 1, no, again, this is false, right? Return number plus add recursion number minus 1. What is the second step? Let's write down the second step. Step 2. Return 2 plus add recursion, recursion 1. So this is the second step, right? Okay, this is the second step. So in the second step, what it does is it returns 2 and then it says add recursion 1. So Now in this statement, inside this statement, it is 2 plus add recursion 1. So again it calls itself. What is the argument here? It is 1. So now 1 goes here. So now it is 1, right? Now it is 1. So this condition is true this time. So return 1. Okay? It returns 1. So the third step is, okay, the third step is actually should I say it? Step 3, it is simply return 1. Okay? Can you guys see this? Okay, step 3, return 1. So now let's write this again. Let's open another thing. Okay, can I just remove it? Oh, I cannot. Okay. Oh my god. Okay, let's remove the whole thing. Okay, let's remove the whole thing. Since you know the steps, I will write this again. So let's remove all the thing, everything, everything in this page. Delete it. Okay. Now let's just focus on the steps. Step 1, return 3 plus add recursion 2. Okay, this is the first step. Now this is the second step. It is like a ladder. Remember this thing. It is like a ladder. Return 2 plus add recursion 1. Now again, since it is a ladder, here will be step 3, which is the final step. In step 3, all it does is return 1. Okay. So now let's understand the flow. Let's take a brush. So in the first step, it goes like this: return 3, all good till now, add recursion 2. Now when you make this call over this thing, when you do this, it now executes another function call, which results in this step 2. Inside step 2, return to all good till now. Now when you say add recursion 1, this thing again, okay, bad, okay, this thing again calls another function, and finally this will execute another function. Finally this is returned 1. So what is the final value? 1. So that means this will be replaced by 1. So what is 2 plus 1? 2 plus 1 is 3, right? Okay. 2 plus 1, 3. Now, since this thing over here called this one, that means this will be replaced by 3. Now, 3 plus 3 gives you 6. And this is our answer. Okay. So did you understood how did we came this way? We started from here. It called this thing called another, itself. This thing called this one, and it ended. Why did it end it? Because after this, no calls were made. Simply returned 1, and no calls were made. So execution completed. That's how it worked, right? Should I show it again, guys? Let's make it more clear. This thing call this whole thing, okay, and whatever is the final value of this thing will come here, okay, will come here. This thing called this whole thing, whole step 3, and whatever the value here will be replaced here, okay. So the value is 1 here, so this will cancel out, it will become 1. So 2 plus 1 gives you 3. Now the total value is 3, so this will, so this will cancel out and it will become 3, and so the final answer is 3 plus 3, which is 6. That's all, guys, okay. That's how you can replace loops. I know it is actually complex than loops, but it is a faster way of doing things, okay. Now let's see another example. Let's clear it out. See this, okay. Again, let's start the Python interpreter. Now, do you guys know what a factorial is? Okay, time for factorial. So what are factorials? Have you ever faced factorial numbers? Factorial numbers are nothing but, let's say, if I say, tell me 5 factorial, factorial of 5. So what is factorial of 5? Factorial of 5 is nothing but 5 into 4 into 2 into 5 into 4 into 3 into 2 into 1. That is factorial 5. If I say tell me factorial 10, you will say 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That's what you say. If I tell you give me factorial of 30, you will continue from 30 into 29 multiplied by 28 multiplied by 27 into 26, and you will continue to 1, right? You will actually not continue to 1, actually you will continue to 2, right? So again, there are two ways of doing this. Using loops, you can continue from, let's say you give factorial 30, so you will continue from 1 to 30, 1 2 3 4 5 6 to 30. But in case of recursion, you will come down in a reverse way, that is 30 29 28 27 26 till 2. That's how you will go. So now let's begin, okay. I hope you guys understood what factorial is. Factorial is nothing but, if I say give me factorial 3, you will say 3 into 2 into 1. So every time you will reduce 1. That is the concept. That is the mathematical concept. Now let's code this out. I'll remove this because we will need this later on, and I will make sure you guys understood. Okay, so let's define another function. Okay, does this work in? It will work, right? Nope. Okay, it works finally. Okay, so do you see this? Before going into any further on this topic, do you see this thing? Help on built-in function, print in module built-ins, right? You see this? So help is a built-in function, and print is also a built-in function. So whatever we give inside help will tell us how to use print, right? So this is how you use print. Print value, okay, leave this one, but this is how you use print. But let's say you define a function called def square. It takes a number, and let's say it returns you number star 2. Okay, so now if you say square 2, so the square of 2 is 4. Now if you say help square, so it won't give you anything. It will only tell you the parameters square function uses. What is the parameter? Number. But if you want additional information to be displayed, we can do the same thing, okay. You can say def square number, this is a parameter, and this is a doc string. You will say, you will write triple quotes and write this function, whatever you write inside this will be displayed when you when you execute this one. Okay? This function calculates the square of a given number. Okay. Started with 3 quotes, ended with 3 quotes. You can also write multi-line. This is multi-line string in Python. Remember I told you last time? This is made by Subhodeep. And this now return number 2. It does the same thing, right? Let's check this out. Again, it does the same thing. Now if I say help square, see, the same thing is printed out right here. So this is called docstring. Docstring is the manual book for how to use a function. Okay, how to use a function and what a function does. Everything about a function is written inside this. So this is a docstring. Remember the name, and you will use this a lot, because if you do not use it, your code won't be human readable. People won't understand what you have done inside the code. Anyways, so let's get back to the factorial thing. So what is factorial? If I say give me the factorial of 5, you will say 4 in, okay, 5 into 4 into 3 into 2 into 1, 120, right? This is the factorial of 5. If I say give me the factorial of 3, you will say 3 multiplied by 2 multiplied by 1 is the factorial of 3. So you can obviously use loops for this purpose, right? So let's define a function. Let's say factorial loop, and it takes a number as a parameter, and there is a temporary variable called total or sum, whatever you say. But remember to make this 1, because you are multiplying. Remember this, you are multiplying, you are not adding. So if you multiply anything with 0, if you say this 0 and you multiply anything with 0, it will give you 0 ultimately. So remember to make this 1. For x in range, start from 1, go to the number plus 1. Total, then total equals to total multiplied by x. Or you can directly say, okay, you can do it my way and simply say, what the hell is happening? Hey, my computer is malfunctioning or what? Anyways, you can either say total equals to total multiplied by x, or you can directly say total multiply equals to x. This is the same as writing the previous one. Okay. Finally, you will say return total. So now if I say factorial loop and I say 3, it will give me 6. If I say 5, it will give me 120. So you can see it's working, right? So this is one way using loops. But if we use recursion, now let's define another function. Define factorial recursion. Again, it takes a number as a parameter. This is the base case. Okay, first use docstring. You can use double quotes or you can use single quotes, that's completely up to you. And write this function calculates factorial of a given number using the concept of recursion. You can call it using factorial recursion argument. Okay, and you will say okay, perfect. Now let's give the base case, and this is where you have to stop. This is where you stop, right? What is the base case here? If number less than 2, return 1. Because what is the factorial of 1? It is 1. And then return number multiplied by factorial recursion number minus 1. What is wrong with my Windows? Come on. Hey, what's wrong with my Windows? This is bad. What's happening, dude? Is there something wrong? Return. This won't work. I don't know from where this came from. This is the reason I hate Windows. Return number multiplied by. I know this won't work because due to these things. Factorial recursion. I'll still make it. I'll still try to make it work. Factorial recursion. You will say this number minus 1. Let's see what happens. Okay, let's see if this works. I do not know if this will work or not because of these two parentheses. I don't know where this came from. What the hell? Nice. Oh, I'm sorry. Factorial. So it works. Factorial recursion 3. Let's do it again. Factorial recursion, let's say 5. It gives us 1 10. So it works perfectly. And this is the same as the previous case. So in this case, what is the base case? Number less than 2. So let's see for the numbers. Let's say 4. 24. So do you guys want to see this in Paint? Let's get started. And we will see 4 in this case. Let's write this down. And let's make this a little bit, let's decrease the size a bit, else it will be difficult, to understand. Let's reduce the size and let's copy this up. No, this is 2, 22. Yeah, perfect. I hope you guys can see this. Okay, now let's get started. So let's call it using, say if I call this using factorial recursion 4. Okay, factorial recursion 4. So what is happening here? Let's see. So we give argument as 4 and it goes here, right here. So this is 4 now. So definitely this is not the case till now. Okay, number is not less than 2 because it is 4. So return number multiplied by factorial recursion number minus 1. Let's write this case. This is the step number 1. Can I color this? Yeah, definitely. Step 1. It gives you 4 multiplied by factorial recursion 3. Right? Alright. Okay. So this is the first step. Now, what happens is, I need a black color. Yeah. So what happens is, while doing this, this will again call the same function. So this will become step 2. What is step 2? Let's understand. Yep. I need red again. Step 2. 3 multiplied by factorial recursion 2. Right? Let's extend this. Perfect. Again, while doing this, this will call again same function. Okay, so for the first time it was 4, this was 4, and this is the step 1. While step 1, this thing over here, this thing will generate step 2, and now and this is the same as this one. So this is step 2. Now inside step 2, this factorial recursion will again call this one, call the same function again. So the step 3 is, oops, yeah, so the step 3 is 2 multiplied by factorial recursion 1, right? And finally, okay, let me take the brush. And finally, this will again call the same function. It will call itself. And in the step 4, turn 1. But this is the final step, because return 1 will only return this number. It will not generate any other function. Okay, there is no function, there is only 1. So this thing will be replaced by 1. So 2 multiplied by 1 is 2, right? So the whole thing is 2. So that means this will be removed by 2. 2 multiplied by 3 is what? 2 multiplied by 3 is 6, right? So this whole thing will be replaced by 6, right? Since this thing generated this thing, this will be replaced by 6, right? So 6 multiplied by 4 will give you 24, right? So the final answer is 24 because 6 multiplied by 4, this will give you 24 as the answer, right? So that's how recursion works. So again, you came down this way, now you go up this way, this, then this, then this, and you get the final answer. That's how recursion works. You come down, then you go up. Okay, so that's how it works. So as you can see, our answer has matched. Our answer is correct. Factorial recursion 4 will give us 24. Okay, so these were the two common, very common, scenarios where we can actually replace loops with recursion. So that was it, guys. You understood doc strings, how to use functions, what are recursion, how to use recursion, how to use recursion and replace loops entirely using recursion. So um, these were the real life scenarios. Now let me tell you a IT scenario where you will be using recursion a lot. So let's say you have a folder. Let's say you have a music folder. Okay, you have a music folder. Inside the music folder, you have three different genre folder. So one is for rock songs, one is for pop songs, one is for hip hop songs, right? Inside hip hop songs, there are two folders. One is for artist A, one is for artist B, right? Inside artist A, there are 5 songs. Inside artist B, there are 10 songs. Come out of the folder, you have the hip hop folder. Come out of the folder, you have two more folders. What are those folders? Those folders are okay, pop and rock. Inside pop folder, you have two more folders which has 5 more songs in each. And again, you come back, you have a rock folder where you have two more folders with different artists or singers, and you have 10 songs in each. Now let's say you want to count how many total files are in there. So I know it's a bit complicated, so let's use paint here. This is a IT scenario. This is where you will use recursion, and that will simplify your lives. Delete. Okay, so let's say you have a big folder. Okay, a very big folder, right? Inside these folders, there are 3 folders. This, this, and this. Okay, you have 3 different folders, right? Inside this, there are 2 folders. Okay, again inside this there are 2 folders. Inside this there are 2 folders, right? So let's name this. The name of the folder is, we'll make this big, 36, rock. Rock. Oh, oops, I'm sorry. The biggest folder's name is songs. Okay. The name of this folder is rock. This folder is pop. And this folder is hip hop. Okay. So this is an artist called A. This is an artist called B. The name of this artist is C. The name of this artist is D. The name of this artist is E. The name of this artist is, okay, well, F, right? So let's connect this. Let's connect this. Okay. So this has 3 folders. 1, 2, and 3. Right? This has 2 folders. This and this. This has 2 folders. This and this. This has 2 folders. This and this. Now let's say This folder has let's say 2 songs in it. 1, 2. This folder has 3 songs in it. 1, 2, 3. This folder has 5 songs in it. 1, 2, 3, 4, 5. And this folder has only 2 songs in it. Okay. This folder has 1 song in it. This folder has, well, let's make it 3. This folder has 3 songs in it. So now, if I tell you to count the number of total songs inside the songs folder, what you will do, you will enter this folder first, then you will enter this folder, then you will enter this folder, but then you will not enter any folder because this is the base case. There is no folder inside this. Again, you will enter this, and there is base case. You meet the base case. You enter this one, this folder, then you enter this one, then you enter this one, and you reach base case. So you count. So 2 plus 3 is 5. You get 5. So 5 plus 5 is 10. You enter this one, 12. You get out of the folder. You enter this folder. Now you enter this folder. You get 1. So 5 plus 10, 12, 13. Now you get out of this folder. You enter this folder. Now you get 3 more songs. So 14, 15, 16. You count those. So how many total songs are there? 16. Okay. Am I right? 5, 10, 11, 12, 13, 14. Okay, perfect. So 16 is the number. And you can count this using recursions, right? Recursion is the best way to calculate these things. Now, there is a problem in Python. If you say factorial recursion 10,000, okay? See what you get. Recursion error. Maximum recursion depth exceeded in comparison. See, you cannot recurse after 1,000 times. 1,000 times is the minimum. So let's see. If I say 1,000 times, you will get recursion error. If you say 999 times, you will get recursion error. You will say 998 times. So 998 is the maximum time you can get. But after that, you will get an error. So this is the limitation of Python. Okay, if you were using C or C++, you could have done this easily. But in Python, by default, there is a restriction of 1,000 recursion depths. You cannot go more than 1,000. So 998 is the limit. You cannot go 999 because that will give you recursion error. So that's it, guys, for today. So I hope you understood all the topics. You know now how to use functions. And one more thing, where to use functions? Once again, where to use functions? Where you need to use the same code again and again and again. Make a function and keep writing the same thing. Just call it. Just call the function. So how to call the function? Name of the function, double brackets, put anything inside arguments, send it. So you will call it, okay? So that's how you call a function. How to make a function call? You understood, right? Print hello world. You are making a call, but you are writing a function, def, print, you are writing things inside it. That's your defining function. That's how you define functions. And how you call functions? Print hello world. That is how you call functions. So that is the basic difference. I hope you guys understood, and the video is going to be around 2 hours long. I'm really sorry for that. My videos are always long because I keep on explaining things. Okay. I'm really sorry for the inconveniences. So see you in the next video. And our fundamentals of Python is completed. We are still in unit 1 obviously, but fundamentals, the basics of programming is completed. This was the last topic, which was big, very big. Now we will cover the basic data structures, basic inbuilt data structures inside Python. That is strings. We will have a lot of fun using strings. We will use lists. We will use dictionaries, sets. Set is a mathematical concept, obviously. Sets, and then tuples, okay, all those stuffs. We are gonna use it soon, and then on we will move to unit 2, which is intermediate Python. So till then, see you guys. And yeah, one more thing, I have my exams currently. So today, tomorrow is my database management system exam, and day after tomorrow is my Unix exam. So the next video will be a bit delayed. Till then, watch this, practice this as much as you can. I will give you an assignment soon, or sooner or later. I will give you an assignment because I am busy right now, because of the website. And the website has been started. You guys are requested to send the videos as early as possible. If you want your faces to be revealed inside the website, please send your videos. And if you want to write, please write, and I will share it on the web. Okay, your face will be there inside the website. So see you guys. Till then, bye, goodbye. Um, keep keep practicing and happy Pythoning.